This
Okay.
conference will
Uh,
now be recorded.
okay. Good morning, all. Welcome back. Mm, Yeah, yesterday we tried to install a robot shop project, and we were able to run few services front end and then back end, cart, catalog, and user. We were trying. We need to link those services now. Okay. Mm, so this instance is very small, t2.micro. We cannot run multiple containers in this. I will take one new instance, and or else I install Docker desktop. We can try this Docker desktop. You can also install in your Windows instances if your RAM is at least 8 GB. Okay. Instead of pushing to GitLab and then pulling to the server there running Docker, if that is like more work to you, you can also install Docker desktop. Then you can run the containers in your local. Okay. So since we are taking the new server, we will see the both ways. I'm creating one new server, Docker 2, and AWS Linux. This time we will take this one, T2 dot small or T2 dot medium I'm taking. Make sure you stop this instance, otherwise you will be built a lot. Docker, and then I want to allow all TCP. Okay, edit, add security group, all TCP from all servers. Let me take the storage of 30 GB and then launch instance. Now we need to do everything from the scratch again. We need to install Docker and Docker Compose, and again we can get a chance to run all our services one by one. Okay. So yesterday, when you are not, if you don't understand completely, today we can make it again. Okay, let me take this server. So we need to install Docker, right? So we have our Docker install commands. Just run these commands. Sorry, this is the IP address. I took wrong IP. This is the latest IP. First M update, and then install Docker. Start and enable. Okay. Now we need to set up GitLab access. I use SSH key authentication. You can use whatever you want. SCP. So I have my private key in this system, and then I am using user gitlab.com. In this case, like this, you can use your SSH key authentication while you are pulling and pushing. Okay, same I will copy here in the new server. I need that key also. So the command to copy between two systems is usually SCP, and then EC2 hyphen user. Okay, I should have the private key. It's okay. I can just cat it. Okay, so this one should not have more than 400 or 600. And this one should have 700. Okay, now install Git. And clone our repo. Okay, we are able to clone. So this is a Git setup. Let us use Docker desktop so that it will be very easy for you to practice. Okay, so I installed Docker desktop. It's very simple. Just you need to download .exe and then run it. Okay, I installed Docker desktop. Okay, cd RoboShop. Now everything I will do it in Windows here. Okay, yesterday we did up to some part. Now anyhow we have to repeat it so that you can get more idea. So first let us do this web part. Okay, this is static website and then copying it to Nginx HTML directory. So let me run this here. Cd web docker build -t web :v1 dot.
Bro, I have one doubt.
Yeah, please.
So, do we need to navigate the Docker desktop.exe file, or how it will be, bro? I mean,
You can directly install like any other software in Windows.
okay,
Just next install.
okay. Then, I mean, no need to navigate the Docker exe. We need to go further wherever the Docker file is available in our desktop, right?
Yeah, that's it. Yeah, correct.
Okay.
Now I'm running it in local. Now let us see. It is running. Localhost I mapped 8080. Okay, so we are getting. So let us do it in Docker desktop. It will be easy for you also. Okay. And then, so we were doing login and this one register. So this is the first thing. If you do anything here, you will get error obviously. Because user service is not available. You can just go here and then check. Yeah, this one login. This is not available. Okay, so let us install first user service, and then we have already copied user service. It is a Node.js application, and copying the package.json and installing the node libraries, copying the server file and starting it. Okay, so this will start the user. So let us go to user service. And then docker build -t user v1 dot. I don't know how my system will react after running all the services. Maybe it may crash also. Let us see. It's very slow in Windows. Oh, too much slow. Okay, you just use Docker desktop for practice in local to write Docker files. Let us use Linux only. Docker compose install AWS Linux 2. Follow these commands to install Docker compose in Linux. Still building. So let's go to Linux only. Okay. I installed Docker and Docker compose in Linux. Now let us do Docker build -t web:/v1 dot. And let us go to user. Docker build -t user:/v1 dot. Now let us build our docker compose.yaml from the scratch. I will remove everything. Okay, commented. Can give services web. What is the image we are using? Web:/v1, and let us map the ports. It is opening port 80 and 80, and then container name we give as web, and let us see the depends on. So depends on, clearly it depends on user. If you don't have user, otherwise you will get definitely error. So I'm giving depends on user. Now let us build the user service, user, and then image is user:/v1, and then ports. What is the ports it is opening? Our user 8080 ports 8080:8080, and then container name just give as user. Okay. Now we built the images. Let us pull this Docker compose and then run it. Tomorrow's class we can use Jenkins to build the images. Okay. Docker compose up -t and then Docker ps. Web is not running. Docker ps -a. Web has some error. Docker logs Okay, there is some old configuration yesterday. No, we are not using it. Did we build it? Docker build -t web:/v1 dot. Okay, we didn't build web.v1. Okay, now we built web and everything is running. Now let us access port number 80, login. We are getting error. If you see this Docker logs, so we haven't configured the user service from the web. Okay. So now to configure this, let me simply run a diagram. This is the front-end service. This is the user service. This is Nginx, and this is user. So when I hit /user here, if you see the console, when I'm hitting this, it is going to the /API/user/register. So you need to do some configuration in this here reverse proxy. You need to do some configuration to hit user service. Okay. So when you get the request as /API/user, it should forward that request to the user. So that is the reverse proxy configuration in Nginx. That's why we use Nginx for front-end applications. So that configuration we have here, default.conf. Here, this is the Nginx reverse proxy configuration. Let it listen on port number 80. And here you see here, comment all these things. Now let us do it one by one. What I want is, if somebody hits /API/user, it should go to user. What is the port you are running in? 8080. Okay, let us test this now. I will log into this web docker ps. Let me log into this docker exec-it bash ping. Okay, ping command is not found. Yum update -y. Okay, so what is this release? Debian. Okay. Install ping in Debian. apt-get update. apt-get utils iputils ping. Okay. Now you ping user, you are getting response, because internally these Docker containers are resolving this DNS for you. Okay, so you are able to ping user host from the web host. So I will give here user:8080. Now you need to copy this configuration to etc nginx.conf.t/default.conf. Okay. So now we wrote the reverse proxy configuration and copying to the Nginx, so that Nginx will read this, and whenever it gets the request of /API/user, it forward that request to the user service. Okay, so see here. Okay, now you need to build the images again. So once we are good with this, tomorrow we will use Jenkins to build it. Now git pull docker build -t web:/v1 dot. Okay, and then docker compose up -d. Started. Now let us go and check. We need to resolve the dependencies one by one like this initially. In real time, your developers will tell you. Database not available. So it requires some database user service. Now the error is different. That error is gone. The request is going to the user. There we are getting some error, database not available. Let us see what is it. Docker ps docker logs user MongoDB database error. So we should have MongoDB for user to work. So let us work MongoDB. Already yesterday we have done it. Just getting the MongoDB image and copying some default users and some catalog database sheet. So let us run MongoDB docker build -t MongoDB :v1 dot. So now let us do our Docker Compose. Your user is clearly dependent on MongoDB. So let's have depends on MongoDB and run MongoDB service. Image MongoDB :v1 and then ports. What is the port it expose is 270 something. Okay, I removed that information. Let us check this. It's 27017, I think, is it?
230.
Anyhow, we will, when you're not sure, no need to give, because by default it will connect, or we can go to the user service and then check here. It is connecting to Mongo. MongoDB. (27017). Anyhow, we are connecting to the containers. You no need to provide the port information. This service is connecting through the Docker ports only. Container name MongoDB, and then that's it for now. Git pull. Now let us do Docker Compose up -d. It is checking the dependency and recreating the user because its dependency got changed. Okay, now let us check. Okay, now you see the error got resolved. I logged in. Now we have resolved the user dependency. So similarly, we will resolve the other dependencies like categories and cart. So now let us go through categories. Any doubts still here or confusions?
Yeah, bro, I have few questions.
Yeah, please.
So actually, we are running the each part as a container, right? Like a user as a one container, web as one container, DB as one
Correct.
container, right?
Correct.
All are related
Correct.
to one of the application Nginx, right? So
All
how
are related. Yeah, tell me.
bro?
Tell me.
All the containers are related to Nginx, right?
Yeah, that is why the user configuration. Here, this is
Yeah.
one front end. And now we are going to do the cart and catalog. So we cannot open these services in front end. Front end is only one. These are back end APIs, we call it as. So this front end connecting to this through the API services or microservices or REST services, whatever. So
Okay.
all the
So
requests
how it is
will be hit to, yeah, how it is.
okay? How it is integrating each container? I mean, all the containers one by one, connecting. User is connecting to DB or some database, right? When you are
So
entering the
like this,
details.
this is a reverse proxy configuration in here. It is forwarding the request to the user service. This is another web service running. Similarly, it will forward the request to the cart. Similarly, it will forward the request to the catalog. Connecting through the APIs. These are called as RESTful services.
Okay.
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 Now let us do the catalog. We have catalog here. Docker build -t catalog :v1 dot. Okay, catalog is built. Now let us do the Docker compose. Your front end is again dependent on catalog, and whenever a request comes to the Nginx as catalog, we are forwarding that request to the catalog container on port number 8080. Okay. Now let us write the catalog service here. Catalog image is catalog v1, container name is catalog. Okay, let's pull this. Now you see, first catalog got started. Now we have catalog web everything. Now let us check whether this Nginx is able to call catalog service and get the data or not. Okay, still nothing. There is an error. 404 not found. Let us go and check the error here. Okay, so what happened is I changed something in our web configuration here. I should rebuild the image. Docker build -t web :v1 dot. Okay, after you rebuild, let us go to Docker compose and run. It's recreating. Okay, started. Now let us check. Now you see we got the categories. Now let us add to cart. It is getting error because cart service is not available here. Okay, you see cart is not available. Now we have to add cart service. We have cart here, similarly a Node.js application, and then Docker file, exposing port 80, copying the package.json and server.js and running it. Now the dependency is when category is clicking on cart service is not available. Okay, let us build the cart first. Cd cart docker build -t cart v1 dot. Okay, cart image is built. Now let us do some modifications here. In the front end side, here you need to make this unavailable. Whenever there is a request on API/cart, send the request to the cart application. This should be available here. And inside catalog, there is some dependency on cart. Okay, no dependency. So now your web is again dependent on cart service. Ultimately, the underlying API should be ready before you run front end. Okay. So usually the structure is this one. First, database should be ready. On top of database, you should have your APIs ready. On top of API, you have front end. Then when you request a front end, it will call API and it will call database. Okay, that is the dependency usually in microservices or any application. Now let us enable cart also here. Cart image cart v1 container name. You should not forget this container name, otherwise other services cannot connect with this. Now let us rebuild web. And then do the Docker compose. Okay, I didn't pull it. Okay, you need to remember these steps. Otherwise, whenever you do some change in the image, you need to rebuild and then you need to run it as a container. Otherwise, you will not get the results. Okay, web got recreated. Now let us go and check whether we get any new errors. Is out of stock. Again an error. So this is not found still. We added API/cart. Let us check the errors here. Our cart is running, but still we are getting the 404 error from here. Let us check the logs of cart. Okay, so now the request came here, but the error is regarding Redis. So cart requires some Redis database to store it. Okay, so now this cart is dependent on Redis. Let us create Redis service. We no need to have any image. We can directly call open Redis. Just Redis, that's it. And the container name is Redis. Okay, I'm pulling the image from the internet. I no need of to build any Redis image. then git full. Now Docker Compose up. See, since the cart is dependent on Redis, first Redis is getting pulled and created, and then cart is getting recreated.
Siva, it's me, Senthil here. I have one doubt here. Now,
Yeah.
now we are using the command docker-compose up actually. So,
Yeah.
this particular command, what it does is it will search for this Docker compose file, and it will run,
Yeah.
and it will in that file, whatever the instruction, it will run that. So,
Yeah, correct.
my question is, in this scenario, we have some 2-3 containers already running, but
Yeah.
that same file we are rerunning it. So in that case, it will understand that these 2 containers are already up and running, so it will skip those instruction. Is it like the flow? It will be like this.
Yeah, it is already skipping. You see here. So
Okay.
these containers are already running. They don't have, the cart don't have any dependency on this. So Docker Compose didn't touch these things. It created Redis and then it restarted cart and web.
Oh, it will restart the containers, whatever
Whatever
containers.
the dependency containers, it will restart.
Okay. Okay, sir. Thanks.
Dependency containers only, it will restart. Otherwise, right, if you have 10, 20 containers, you will be confused which one to run first if you don't know the dependency. But
Correct.
clearly it says here the depends on is very much useful for us. If any new person joins also, they can see what service is dependent on what.
Okay.
Okay,
And this
now let us,
particular Docker-compose, we are giving from one path, right? In that path, we should have this Docker compose dot YAML file also should be there within the same path.
yeah, correct.
Okay.
Okay, still error. Did I rebuild web? So whenever you make a service available, you should have an entry like this. Okay, now let us see. If we still get error, then we need to check something else. Now you see it is added to the cart. Now let's go here and you just add another one. Okay, we got 2 items. Then you click on checkout. Now you are getting, you should get some shipping information, which country, which city. You don't have that information. So for that, you should have shipping service. So this shipping service, it's a Java. You can see here Java, and then it is dependent on cart. It is dependent on cart. We have already cart running, and then that's it, cart. And this one is built on Java 8. This is the Docker file for this. So it takes some time actually to build this. I need to explain what is the multi-stage build to you. So we can stop till here today. Tomorrow we can continue. If you have any doubts, we can discuss now. Because this takes more time shipping. Here I need to explain one concept like multi-stage build, and then we can proceed with this. You need to practice till this. Then you will understand the full Docker and Docker best practices. Then we can go to the Kubernetes.
Okay, bro.
Okay, nothing difficult actually. I can make the documentation very clear. The simple rule is whenever you do some change in the image, you should rebuild and then you should properly define the dependency here. That's it. So while you are practicing, just this web, start with nothing here like I did today. First enable user and then enable cart catalog. Slowly you practice this, then you will understand the full flow. So we have just two more, shipping and then payment. When you complete shipping, you will get the data here, which country and city. And when you click on calculate and then checkout, your payment service will be called. So those two dependencies, if you complete, then the full e-commerce application is ready. So this is same like Amazon, but Amazon is like handling more customers, more traffic, nice UI. But the process is same for anything. Okay. So any other doubts? I will upload the video soon, within 1 hour, and then I can clearly write some document here, how to install Docker Compose and what are the steps you need to follow. Okay, you don't need to write everything from the scratch for now. You can just clone this and run one by one. Docker desktop is very slow. Okay, you can directly clone your this Git code in your server, and from there you can build it, and then you can start the services one by one. If you are able to write from the scratch by yourself, that is very good. Okay, any other doubts? No doubts?
Good, bro.
Okay. Okay, then see you tomorrow. Come with more practice by tomorrow. Then we can complete this. We can start Kubernetes from day after tomorrow. I mean, from the next class, once we complete tomorrow.
Thank you.
Okay,
Okay,
have a
sir.
nice
Thanks.
day. See you. Bye bye.
Bye.
Thank you, sir.